You know, in the world of AI vision, for the longest time, the race has been all about size. Who can build the biggest model? But that's all starting to change. There's a new model on the block called Step 3V 10B, and it's proving that being smarter, not just bigger, is what really counts. Let's break down how this thing is completely rewriting the rules. So think about it. Most AI vision systems can look at a photo and tell you that's a car or that's a tree, and that's fine. But the real challenge, the next frontier, is about going way beyond that. It's about genuine comprehension, understanding the story, the history, and all the little unspoken details hidden inside an image. All right, let's put that idea to the test. We're not just going to ask this model to name a building. No, we're going to see if it can show us a deep, almost human-like understanding of what it's looking at. I mean, just look at this analysis. It's incredible. It doesn't just say mosque, it pinpoints the exact location, the Badshahi Mosque in Lahore, Pakistan. It correctly identifies the architectural style as Mughal and even gives you the historical context. But here's the real kicker. It understands the specific features that make this landmark unique, telling it apart from other similar-looking buildings in the area. That level of detail is something most other models just completely miss. So, the powerhouse behind this incredible analysis is Step 3-V-10B. And what's so wild about it is its size. We're talking just 10 billion parameters. In a field that's totally dominated by giant models, this thing is a true underdog. But wow, does this underdog punch above its weight? It consistently outperforms systems that are 10, even 20 times larger. It's living proof that the new benchmark for success isn't about raw size anymore. It's about being incredibly efficient and just plain smarter. And hey, you don't have to take my word for it. The data tells the whole story. You can see it right here. Step 3V, our lean 10 billion parameter model, scores significantly higher than a competitor that has over 100 billion parameters. This is just a crystal clear example of intelligent design winning out over brute force. Okay, so that mosque analysis was just a little taste of what this model can do. Now let's go on a quick tour and see just how versatile it is across a whole bunch of different, really complex tasks. Check this out. It's looking at a seriously complex diagram from a scientific paper. And it's not just reading the words, it's completely deconstructing the whole thing. First, its top-notch OCR tech pulls every single label perfectly. Then, it actually maps out the workflow, understanding the sequence of events. And finally, this is the most impressive part. It synthesizes all that information to explain the big picture scientific goal of the entire diagram. All right, let's switch gears to something a little more down to earth, a standard business invoice. The model can, of course, read the table with no problem, the items, the numbers, all of it, but the real test here is what isn't on the page. And this is what it figures out. It correctly deduces that since there's no paid stamp, no note about payment, it can't confirm the invoice has been paid. Now, that's not just reading. That's logical inference. It's reasoning based on missing information, which is a seriously advanced skill. We all know real-world documents are messy, right? Take this handwritten prescription from France. The model not only translates the French to English perfectly, but it also extracts the most critical information, the patient's details, and, crucially, the exact dosage instructions. This is an absolute game changer for dealing with real-world paperwork. Okay, so we've seen what this model can do, which is pretty mind-blowing. Now let's pull back the curtain and take a look at how it's able to do all this. The secret sauce is really in its unique architecture and its training. So most models have a frozen vision part that's trained separately, but Step 3V uses what's called an unfrozen single-stage pre-training. It basically means that its vision and language parts learn together, right from the very beginning. The result is this incredibly deep, seamless connection between what the model sees and how it thinks. And the components themselves are a really powerful combination. It's got a 1.8 billion parameter vision encoder working with a very capable 8 billion parameter language decoder. And all of this is trained on a massive data set of 1.2 trillion tokens, which is how it builds that deep, foundational understanding of the world. Here's another really clever part. Its reasoning is adaptive. For most tasks, it uses a very efficient single line of thought. But when it hits a really tough problem, it can switch into this parallel, coordinated reasoning mode. It's kind of like going from following a single train of thought to suddenly consulting a panel of 16 different experts all at once to find the absolute best solution. And does that parallel mode actually make a difference? Oh yeah. On a really tough benchmark test, the standard mode gets a very respectable 87.7%. But when it kicks into parallel mode, that score jumps all the way up to an incredible 94.4%. That flexibility is a huge part of its success. So when you put this all together, the jaw-dropping performance, the amazing versatility, and this really innovative architecture, it becomes pretty clear that Step 3V is a huge milestone in AI. So the key things to remember are pretty simple. Step 3V delivers absolutely top-tier results in a much smaller package. It's a master of deep contextual understanding, not just basic recognition. Its unique training creates a seamless bond between vision and language, and its 2 reasoning modes give it the flexibility to solve almost anything you throw it at. The success of this model really signals a massive shift in how we should be thinking about AI development. For years, it was all about building bigger and bigger models. This proves that the new frontier isn't about brute force. It's about intelligent design, efficient architecture, and a fundamentally smarter way of building AI.